Welcome to you in this first lecture. In this lecture, we will discuss about the quantum mechanical operators. Okay. So the quantum mechanical operators of angular momentum in Cartesian coordinate. So quantum mechanical operator of angular momentum in Cartesian coordinate. So these three terms are the main concept of this statement. So quantum mechanical operator means that just like as differential equation is also operator, it may be partial differential equation or ordinary differential equation. These are two operators. Okay. So when we talk about Cartesian, then it means that we want to find the operators of angular momentum in x, y and z. Okay, in x, y and z direction. So as we know that the classical equation representing the angular momentum, of a particle is given by, and what is the classical equation? The classical equation, if the angular momentum is L, then the classical equation will be just like L is equal to R cross P. Okay, this is the classical equation of angular momentum. And now we write this equation in component form, Cartesian coordinate. Just like we will write L in three coordinates, Lx, Ly and Lz, and similarly we will write the component of R. Okay, and also we will write the component of P. And we know that L can be written in as Lxi unit vector plus Lyj unit vector plus Lzk unit vector. And the component of R is xi unit vector, yj unit vector plus zk unit vector. And similarly, the component of P are just like it is pxi unit vector, pyj unit vector and pzk unit vector. Okay, and after writing this equation in Cartesian coordinate, L is equal to R cross P, we write it in Cartesian coordinates. Remember that here I, j, k are unit vectors in the direction of x, y and z respectively. Okay. Now write this equation, above equation, in operator notation. The above equation is not in operator notations. When we write in operator notations, we write a cap on L, similarly on x, y and z, and similarly on px cap, pxy and pz cap. Okay, so but we will not read just like as, we will not read it cap. Okay, we will read it operator. So now we are writing over here Lx operator, just like Lx I unit vector, Lx operator, okay, plus Ly operator, okay, j unit vector plus Lz k and operator is equal to x operator I unit vector, x operator I unit vector, y operator j unit vector and z operator k unit vector. Okay, and similarly you will write px operator I unit vector, py operator j unit vector and pz operator in k unit vector. Okay, now we write this equation more precisely. We will put the value of px. The value of px is what it is, minus iota h cut, partial over partial x, and the value of py operator is minus iota h cut, partial over partial y, and value of pz is minus iota h cut, partial over partial z, k unit vector. Okay, in the next step we will take common minus iota h cut. Okay, here we are taking minus iota h cut common from the second bracket, second parenthesis. The first will be written just like as multiply by minus iota h cut is common, so you will write partial over partial x I unit vector, partial over partial y j unit vector and partial over partial z k unit vector. Okay, After writing it, we will write this in determinant form. Okay, there are two vectors. The first vector is x operator I unit vector, y operator j unit vector, z operator k unit vector, and similarly the second operator is partial over partial x, I unit vector partial over partial y, j unit vector partial over partial z, k unit vector. When we write in determinant, we will write the component of I, j and k. The component of I, j and k is x operator, y operator, z operator, and partial over partial x, partial over partial y, partial over partial z, and you will write then in determinant. Okay, after writing it in determinant, we will now open the determinant. So first we know that how to open the determinant. It is very obvious and common how to open 3 by 3 matrices determinant. So now in this step we are opening the determinant. First we will take I unit vector, we will skip that row and that column. Okay, yes, I unit vector minus. Now you will write for the j unit vector. When you will take the j unit vector, you will skip that row and that column. Okay, and similarly for the k unit vector, you will skip that row and that column, and this is for the k unit vector. Okay, in the next step what we will do, we will multiply minus iota h cut inside the bracket. Okay, and separate the I, j and k. Before doing this, we will write the left hand side, which is lx I unit vector, ly j unit vector, and lz k unit vector. Okay, let me write first. Lx I unit vector plus ly j unit vector, left hand side, okay, plus lz k unit vector in operator notations. Okay, now we will multiply minus iota h cut inside y partial over partial z minus z partial over partial y, and it will be written in I unit vector. Okay, yes, I unit vector, and similarly we will multiply minus iota h cut with j unit vector. Okay, yes, plus minus iota h cut partial over, yes, it is z partial over partial x minus x partial over partial z, and close inside the square brackets, and it is g. Okay, plus minus iota h cut x partial over partial y minus y partial over partial x, and then we write the k unit vector. It's okay. So after writing it, now we will compare the left hand side and right hand side. So what are the components of I in left hand side? It is lx, and in the right hand side it is minus iota h cut y partial over partial z minus z partial over partial y. We are comparing the component of I, j and k on both sides, left hand side and right hand side. Ly is equal to, it is minus iota h cut z partial over partial x minus x partial over partial z, and this is now lz, the third, the component of k unit vector. It is on the left hand side it is lz, and on the right hand side it is minus iota h cut x operator partial over partial y minus y operator partial over partial x. So these are the quantum mechanical operators of angular momentum in Cartesian coordinate. Okay, which are operators for components of angular momentum. So here we are discussing about the application of principle of superposition. the principle of superposition allow us to form a state which is superposition, which is a state which is superpositions of any number of states. That is, any number of states means that psi is equal to a1 psi 1 plus a2 psi 2 plus a3 psi 3 plus up to so on, and this will be written in summation form. And when we write it in summation form, it will be written just like as I is equal to 1 to n ai and psi I, okay, in summation form. And there is another condition, and that condition is ai, where ai mod square is equal to 1. Yes, this is the condition. So to represent a state, this equation should be satisfied. Okay, corresponding to probability of finding a particle, probability of finding a particle in the state, representing by psi I. Hope you have enjoyed this lecture, and I will meet you in the next lecture.